All right, so Shina, let's start off, right? Let's start off with the corrections. Convert each of the following to SI units, to its SI unit, and determine which quantity is larger. So, Shina, what quantity are we measuring in part E?
Meters.
What
What
quantity?
SI units you convert it to? Or
I'm asking you what quantity. So centimeters, meters, that's what quantity. What are we measuring there?
ah, centimeters, 500 centimeters, 0.5 meters.
Nah, I was looking for length. We're measuring length there,
Oh, well,
right?
right,
Yeah, we're measuring length. And what's the SI unit for length,
meters.
right? So we would have to convert 500 centimeters to meters. How would I do that? What does centi mean? Do you remember what centi means?
No, sir.
No. Um, okay, so how did you do it? You just, because we know that in 1 meter, you have how much centimeters,
100.
right? So what would you do to go from 500 centimeters to meters? Wait, so,
25. 25 by 100.
right, but you don't know what centi is. So remember when we looked at the prefixes and stuff, did we do centi? Or we just look at milli, micro, nano? Oh, we did look at centi. Check it out. Check it out, Shina. What does centi
Yes,
mean?
sir.
What does centi mean?
20 power minus 2.
Right. So what I wanted you all to do is remember the prefixes and just multiply. So
And
that's
also, do you think with this one, I did actually others, but centimeters, unlike meters, is such a basic conversion
yeah,
that
yeah,
I did,
yeah.
yeah,
Understand what I mean, right? Just divide that by 100, right? And that'll be 5 meters. So 5 meters or 0.5 meters. Which one is greater?
5 meters.
Right? Part B. Again, what are we measuring there? What
Length.
length, right? So once you remember the prefixes, it's really, really simple. You could do the old-fashioned way, or you can do like this. I'm gonna stick with the physics way with the prefixes. So what does kilo mean? What does kilo mean? Tell me, Shina.
10 to the power 3.
Right? So 6.5 by 10 to the power 3 meters. And we're comparing that to 65,000 centimeters. So that would be 65,000 multiplied by 10 to what power? Per centi,
Minus 2.
right? Meters. So 6.5 by 10 to the power 3 is, let me get a calculator. Yeah, so 6.5 by 10 to the power 3. What's that?
6,500.
Right, that's 6,500 meters. And what is 65,000 by 10 to the power minus 2? We don't need a calculator. We just shift the decimal place 2 spaces to the, since it's to the power minus 2. We shift the decimal places 2 spaces to
Left.
the left, correct. So that would be 650 meters. Did you get that?
Yes,
Great. So which one is bigger?
650 meters.
Right. Okay. C, 0.018 megawatts or 180 kilowatts. Okay, what are we measuring there? Starts with P. Do you know about watts? Do you know what watts measure? Starts with P. Shina, do you know what we use watts to measure.
No, sir.
Nah, power. We measure power
Oh,
using
yeah.
watts. Power. So we have 0.018 mega. Mega means 10 to what power,
6.
right? So that'll be 0.018 by 10 to the power 6 watts. And then we have 180 kilowatts. What does kilo mean?
10 to the power 3.
Right. So what is 0.018 by 10 to the power 6? That should be 1 8 followed by 4 zeros. Let me check. 0.018 by 10 to the power 6. 3 zeros. Okay. 1, 2. Yeah, 3 zeros. So that'll be 18,000. Did you get 18,000?
Yes, sir.
Okay, cool. And for 180 by 10 to the power 3, that's simple. That would just be 180,000, right?
Yes.
180, 1, 2, 3. So which one is bigger?
180,000.
Right. Part D, 1 week or 600,000 seconds. What's the quantity we're measuring there?
Time.
Time, right? So this one a bit different, right? You had to use your common knowledge for this one. So in 1 week, how much days you have?
70s.
7 days, right? And in one day, how much hours you have,
24 hours.
right? So we're gonna multiply 7. So we're gonna multiply 7 by 24, right? And you should also know in 1 hour you have how much minutes,
60 minutes.
and in 1 minute you have how much seconds,
50 seconds.
right? So if you combine that, how much seconds you have an hour? So let's see. So in 1 hour we have 60 minutes, and each minute is 60 seconds. So how much seconds we have in 1 hour?
You have 60 seconds in 1 hour. Oh, sorry,
Wait,
crap.
wait,
What did
wait, wait.
you mean?
Yo, hey.
So I misunderstand, yeah?
Uh, wait, so let me run that back one more time. So in 1 hour, we have 60 minutes, right? And each minute has 60 seconds. So if we have 60 minutes and each,
300. 3,600 seconds.
right, I catch you lacking there.
So I swear I had my homework correct. You could watch it back.
No, no, I know you do the correct. I notice you have that habit. Like you do the correct thing. They go see the wrong thing. And it's not because of cheating, it's just that I don't know. I used to do that too. Right? So in 1 hour, we have 3,600 seconds. So hear this now. Um, if we know that 1 week is 7 days, and we know one day is 24 hours, then in 7 days altogether, it would have how much hours? 7 by 24 is 168, I think. Is it?
Yes, sir.
Okay. Right, 168 hours. And hence we know how much seconds it have in an hour now.
Yes, sir.
Yes, um so 1 week will be equal to 168. So you have 3,600 seconds in 1 hour. So we have 168 hours. I'll multiply that by 3,600. What are you getting? If I could do that mentally, that would be insane, right?
Yes, sir.
Don't tell me. 8406. 6048, followed by 2 zeros. I think
Yes.
604800. Yeah, that's correct.
Yes, sir.
Um, so this is what we get.
Yes, sir.
Okay, and that'll be seconds. So what which quantity is larger? 1 week or 600,000 seconds?
1 week.
Right, 1 week. Shay, are you there?
Yes, sir.
Okay, Shay. Part E. Help me with part E. We have 1,800 milliseconds or 18 seconds. Which one is larger? And before you answer that, what quantity are we measuring there?
Time.
Time, right? So what does milli mean? Milli is 10 to what power?
-10. I mean 3. Is it negative?
Yeah, -3. And you would just move the decimal place 3 spaces to the what?
3 spaces to the left.
Right? 1, 2, 3. So that'll be 1.8, 1.8 seconds. Shane, I got that.
Yes, sir.
So which quantity is larger? Tell me, Shane. 1800 milliseconds or 18 seconds,
18 seconds.
right? And F, 4500 micrometers or 45 millimeters. What quantity are we measuring there? Tell me, Shane.
Length.
Length. What does micro mean?
Micro is 10 to the power of -6.
Right? And we comparing that to 45 millimeters. So milli is 10 to what power?
-3.
Right. So once you remember your prefixes, you fix, like you're real good. You're real good. Right? So 4500 by 10 to the power -6. So 1, 2, 3, 4, 5, 6. I looking like 0.04. Shina, what do you get? 0.004, 0.04.
0.004.
Okay, cool. 0.004. Right? 5. And as we got 0.0045.
Yes, sir.
Cool. And she, 45 by 10 to the power -3. That would be what?
0.045.
0.045.
Yes, sir, sorry.
Okay, so which quantity is larger? Is it the 4500? What's it? Is it the, wait a minute. Where I get me? Where I get seconds from, boy? I read all the time on that one. I don't know if you see what I did there. Sure, you see what I did there? It's not supposed to be seconds, it's supposed to be meters. And so I said I was real out of time in because I don't know where I get time from. Real
I could have
stupid.
sworn it said second.
No, it's
Oh,
meters.
it's meter.
I
Okay,
don't
my
know
bad,
I
my
don't know
bad, my bad.
what are we out of time in. I don't know where I get seconds from. But which quantity is larger? Is it the 4500 micrometers or the 45 millimeters?
45 millimeters.
Yeah, cool. Part two. Right? So Shane, I'll give you a little break. Right, Shay, part two. Read part two for me.
The speed limit on Trinidad's highway is 100 kilometers per hour. Convert this value to meters per second. A driver received a ticket while going 24 meters per second on a 18 kilometer meter per hour road. Did he exceed the speed limit?
Okay. So we had to convert 100 kilometers per hour to meters per second. Let's see if you remember how to do it. So how will I do that? Walk me through the process.
First, you would have to convert the 100 kilometers to meters.
Right? So we have 100 kilometers over 1 hour. Right? How would I convert 100 kilometers to meters?
Well, since there's 1,000 meters in a kilometer, you multiply by 1,000,
And another
and
thing,
you get
yeah, tell me.
you would since there's 1,000 meters in a kilometer, you would multiply by 1,000, and you'll get 100,000 meters. Or
Correct.
that.
Yeah, correct. Yeah, you're fine. And then what about the 1 hour? What are we doing with that?
Well, we know there's 3,600 seconds in an hour, so
So good. So let's see what we get. right? Um, are you all getting 27.78 meters per second?
Yes, sir.
Yes, sir.
Cool. Isaiah, did you get 27.78 meters per second?
Yeah.
Okay, great. So guys, we just did indices the other day, right? We just did indices. Does everybody know that meters per second is the same thing as ms minus 1? Do we understand that it's the same thing? Because this is, notice s is in the denominator and it's understood to be to the power 1. If you bring it up, it'll be m by s to the power minus 1. Shay, are we confused or like you understand that?
Understand.
Sheena, confused or you good?
Okay.
Okay, cool. All right, so was this driver going past the speed limit? So a driver received a ticket while going 24 meters per second. Oh, that's a different question. All right. On an 80 kilometers per hour road, did he exceed the speed limit? So Shay, how would we do this? How would we do part B?
Isn't there like two ways you could find out the 24 into the kilometers per hour, but I did it the other way around. Like changing the 80 kilometers per hour to meters per second.
Yeah, you could do it in two ways. So you're saying, well, you could convert both of them to kilometers per hour. Yeah, that what you're saying?
Yeah, but I did it the other way.
That's correct. And what you're saying is also correct. For the fun of it, let's try to do the opposite. Let's see if we could convert that to kilometers per hour, shall we? So if we have 24, but the standard thing is to convert it to meters per second, because in physics we always work with SI units. But let's just see if we would be able to do it. So how would we convert 24 meters per second to kilometers per hour? Let's see if you could do it. So we have 24 meters per 1 second. How would I convert meters to kilometers?
Divided by 1,000, so multiplying it.
Right, so I will multiply it by 10 to the power minus 3. Wait, did I confuse you there?
No.
No? Okay, good. Because dividing, just if any of you are watching this recording back, dividing by, okay, if I divide something by 10 to the power 3, it's the same thing as multiplying by 10 to the power minus 3. Let's see why. If I'm dividing something by 10 to the power 3, that means 1 over 10 to the power 3. And if I bring it up to the top, that would be 1 by 10 to the power minus 3. Shayna, let me know if that confusing you. We're saying multiply by 10 to the power minus 3.
No, sir.
Okay, would you prefer me write it like this or just say divide by 10 to the power 3? Anyone is fine or like you prefer to divide by 10 to the
Yeah,
power? Okay, and 1 second. We have to convert 1 second to hour. How would we do that? Tell me, Shay.
Um, will we divide into the 3600 instead?
Yeah. So you're just doing the opposite, right?
All right.
So let's see what's gonna happen. So 24 by 10 to the power minus 3. 1 divided by 3600. Okay, we're getting 86.4. And that would be 86.4 what?
Kilometers per hour.
Right, because we converted the top to kilometers, and we converted the bottom to hours. So was the person exceeding the speed limits?
Yes.
Yeah. When you guys get your license, will you all be exceeding the speed limit?
My mom said I'll be driving too slow, that I'll get ticket for driving too slow.
Oh, for some reason I was expecting you to say that you drive fast.
I do, but like when I practice, I do, but I feel like when I actually hit the road, it'll be scary.
Uh yeah, it feels kind of scary, yeah. But I thought you was gonna say yes, and I was gonna tell you, well, hey, you're in the last class, you did say how you did like to eat things in the chemistry lab. So I was like, maybe you'd incriminate yourself even more.
Oh,
Oh, I didn't forget that, you know. Shit, you forget that?
No, sir.
oh
No,
my God.
Isaiah, you remember that? She saying that
Yep.
she way boy she. Don't worry, she. If you ever get in trouble, you ever try to pull a Breaking Bad something, all of we go lie.
No.
All of we go lie because say we don't know you. We didn't even know your name, right? Yeah. Right? Okay. So this was easy. This is an easy question, and that could come for the exam. All right, question 3. Okay. Shina, you'll help me with A and B. Isaiah, you'll help me with C and D. And Shay, E and F. Right? So Shina, and we want to convert everything to standard form to 3 significant figures. Before we begin, Shayna, do you know what a significant figure is?
Yes, sir.
Okay, good. I just clarifying. Just clarifying. So the first one is 4,200 joules. So Shayna, 4,200 joules. I'm going to start off over here and I'm going to shift my decimal place one space before the first significant number. So 1, 2, 3. 1, 2, 3. So that would be 4.2 multiplied by 10 to what power? Shayna,
3.
how much?
3.
3, yeah. And if I wanted to check if my answer was correct, how could I do that?
Just work out 4.2 times 10 to the power 3.
Right. Ladies and guy, did you all know that you could set your calculator to a specific mode so that you don't have to do any rounding off? Did you all know that?
Yes, sir.
Yeah, the Casio calculator, you could set the the degree in which it rounds off. So if you wanted to get all your answers to 2 decimal places, you could do that. Yeah. Right. So the first one is that. Let's check out the second one. We have 101,325. So again, Shina, we're gonna start off at the rightmost. Then we then we're gonna shift it one space before the first significant number. So tell me, Shina, tell me when to stop, right?
Yes, sir. This is
Okay. It wasn't expecting me to go so fast.
yes.
Oh, so that was 5 spaces to the left, and that would be 1.01. Should I continue? Should I
No,
continue?
sir.
No, because it said to round it off to how much?
3 significant figures.
Right. So the first significant figure is 1, then we have 0, then we have 1. Number after 1 is 3. 3 is less than 5, so we just remove everything past 1. So 1.01. Did anybody get that wrong? I guess everybody get it right. And you raise it to the power of 5, right, Shina?
Yes, sir.
Cool. And the unit for that was pascals. Do you all know what we meant? Do you all know what pascals is measure?
Pressure.
Yes. Right. Isaiah, help me with this one. So we have 300 million. So Isaiah, what answer did you get for this?
3.00 by 10 to the 8 meters per second.
If you could tell me what constant that is, 4 extra
Speed of
points.
light.
Pick up yourself. Ladies, did you all know that this is the speed of light? 3.00 by 10 to the power 8. Oh, and we should have write 4.20 over here, right? Yeah. Ladies, did you all know that this is the speed of light? Yeah or no?
Um, Only because of the question on that, where it told us.
Oh, okay. All right. Isaiah, help me with part D. So that'll be 0.03749 kg. So Isaiah, we'll start. The decimal point is over here. So we would move it 1, 2. So that'll be 3.7. And notice the number after Okay, they wanted it to three significant figures. So the third significant figure is 4. The number after 4 is 9. So what are we going to do, Isaiah?
Change 4 to 5.
Change 4 to 5. So that's going to be 3.75 by 10 to what power? We went
By
to
10
the
to the
right.
subtract 2.
Yes. And that'll be PG. Right? Shay, help me with E and F. Shay.
You would move the decimal point to the right, causing it to be a negative power, and it will be 4.5 multiplied by the power of -6. 10 to
Hold
the
up.
power of negative. Oh,
Hold up. Wait a minute. Something ain't right. You know what I mean? Do you know what I mean? Yeah.
wait, what? Yeah, I do. Oh,
Hold up. Wait a minute. Something ain't right.
yes.
Yeah? Okay.
I
Um,
told my friend yesterday about the meme yesterday, and she knew it, so
okay.
I ain't
Maybe
old.
maybe your group of friends just intellectually stimulated. You know, they have the culture, right?
Yeah, it's probably not.
So here what? Shit, you would lose marks. They set to three significant figures. When you move the decimal place one space before the first significant number, look at what's happening. This would be 4.599.
5, 9.
And
Yes.
yeah. Okay, what's the third significant figure here?
9,
9. What's the number after 9?
9.
So we're gonna add
Round
one
off.
9. And if you add 1 to the 9, that will turn to
4
10.
point,
Okay. And it will turn to what?
4.6.
Yeah, 4.6, right? So it really supposed to be 4.60 by 10 to what power?
10 to the power of -6.
Right. And let me see how bad all it is, right? Let me see how bad all it is. If they asked you to write it using the prefixes, this would be 4.60 watt meters. Let me see.
Micro.
Ooh, a little bad. Hey, big up for yourself. Nice, nice. They could do that, you know. They could do that. Right? So F. F is 0.009859 hertz. I feel like we're doing maths here. This is not even physics. I sometimes I just feel like I just teach in maths 3 times a week. Right? So Shay, tell me what to do for this question.
You're doing the same thing as the last one, moving it to the right, moving decimal spot to the right, and
Yeah.
it'll be
Yeah. So is that three spaces to the right?
yeah, and that will equal to 9.9 because you're rounding it off from the. Oh no, actually, it will be 9.86
Right. 9.86 by 10 to the
multiplied
power.
by -3.
Right. Sheena, if they asked us to write it using the prefixes, this would be 9.86 watt hertz.
Really?
Yeah. Yeah, that's correct. I was Shit, should I make the joke I was gonna make?
I always say yes.
Yeah, okay. Um, I fear that some people might put love here because love hurts.
I would never think of that.
I don't know. I just be thinking about these things. My mind would just be doing a bunch of side quests. Shayna, don't put any exam, eh? Don't put any exam. Don't put love here. Hurts. Millie hurts. Right. So we're down 3. Isaiah, help me with question 4. Right? Right. So I'm gonna read the question, right? And Isaiah, you'll walk me through it. A light year is the distance it takes for light to travel in the span of 1 year, 365 days. The speed of light is estimated as 3 by 10 to the power 8 meters per second. Calculate the number of seconds in a 365-day year. So, Isaiah, we need to calculate the amount of seconds. So, before we do anything, Isaiah, tell me, how much seconds we have in a day? Do you know?
3600 times 24.
right? So seconds in 1 day. So in 1 day, we have 24 hours, and in 1 hour, there's 3,600 seconds. 24 by 3,600. That thing that will be 86400.
Yep.
86400, right? Seconds, but is that the final answer?
Yeah, you have to find for 365 days. So you
Right.
have to multiply by 365.
Right, seconds in 365 days. Shay, I don't believe you did up to this point. Yeah, no.
Oh, we did light.
Say that again.
Like we
I can't
we
hear you.
did light, but like I
You
don't
did?
think we did light, but like I don't think it was this intense. I don't know.
Oh no, asking you if you reached up to this point in the homework.
Oh, nah,
Okay, so
nah,
after
I don't.
after I do this question with Isaiah, I'll go through with you to make sure you understand it.
All
Yeah.
right.
Isaiah, so what is 86,400 by 365?
3.15 by 10 to the 7 seconds.
3.15 by 10 to the power 7 seconds.
Yep, yep.
Let me just verify that. All right, here what I would do, Isaiah. I would actually store the full value in my calculator. That's what I would do. So I'm going to store it under A, because in physics, you want to use the exact value in your calculations, right?
Yeah.
Yeah. All right, so Isaiah, since you understand this question, I'm sure you do. I'm going to call upon Shay because she didn't do it. Shay, now I know you did it. Shay, you really wasn't feeling well, or?
Yeah,
Okay, I will take your word for it. You never didn't do homework in the past, and you did attempt it, so I'll give you the benefit of the doubt. So, Shay, is there anything you did not understand about the first part?
no, sir. I
Yeah.
understand everything.
Great. So when somebody wasting your time, you see how much seconds they're wasting?
Yes.
Yeah, because 1 year have 3.15 by 10 to the power 7 seconds. Yeah. Right. So using the formula, wait, why are you reading for? Yeah, Shay, read that question for me.
Using the formula, distance equals speed times time. Calculate the distance in meter, like can travel in 1 year. Put your answers in standard form to three significant figures.
Okay. So hear this, right? They want us to figure out the distance. So D. Do we have to make anything the subject of the formula, or the formula is already there?
The formula is already there.
Cool. So distance is equal to speed by time. Do we know the speed at which light moves? Tell me, Shay, do we know the speed at which light moves?
That's the 3.0 times 10 to the power of 8.
Right. And
Oh,
I think the Casio calculator is supposed to have a list of constants, you know? Yeah, have a bunch here. Yeah,
oh,
the Casio calculator are real insane. Genuinely insane. Most people don't use it properly, right? Like, if you have a Casio calculator, you don't have to remember a good bit of constants in chemistry. At this level, or you don't have to know that much constants, but when you do A-level chemistry, you'll see. So the speed of light is 3 by 10 to the power 8. And I'm going to put the units because I want to prove a point. 3 by 10 to the power 8. And what's the unit for speed, Shay?
uh, speed.
Yeah, I don't know this one. Come on. Speed.
Distance by time.
No. Speed. Do you know the units for speed? Okay, do you know the formula for speed?
No, we did distance by time.
No. Speed is equal to distance over time. Wait, let me ask you a question. So, like, we did some
Oh,
question.
that'll be the meters over seconds, which is the ms with power -1.
Yeah. You had a little moment there because we just want to do a question that was talking about speed, remember? Kilometers per hour, meters per second. Yeah. Right? So the unit for speed is meters per second. Understand?
Yes, sir.
And we just don't find how much time is having in 1 year. So what's the time for one in 1 year?
Can I repeat the question?
What's the time in seconds for 1 year?
Oh, that would be the 3.15 by 10 to the power of 7 seconds.
Now I want you to forget everything but the units. So we have meters per second multiplied by second. And remind me, what are we trying to find for in this question?
Can you show me the question again?
Okay, that's question. Part two, for part two,
The distance of light.
the distance. So look at the units, pay attention to the units. We have meters per second multiplied by seconds.
All the seconds will cancel off each other and they're just equal to meters.
Isn't that crazy? Yeah. You would tell me if the teacher in school share that. I don't know why people is gatekeep, but because of that, that saved me so much thing to remember. I did just look at units and figure out the formula. Yeah. Shina, I wanna reiterate that. So Shina, we're trying to find for what in 4 part 2.
The distance of light.
And what do we measure distance in?
Meters per second.
Distance?
Sorry.
Take your time. Distance. What do we measure distance in? Taking a little while. A little.
So the one thing I understand why you're trying to ask me, I want to know.
What do we measure distance in? What's the unit for distance? So like, let me give you an example, right? You'd measure time in Kelvin. You'd measure mass in kg. You'd measure weight in newtons. What do you measure distance in?
Meters, sir.
Meters. So, Shayna, do you agree that my final answer supposed to have meters as a unit, right?
Yes, sir.
So the formula is speed by time. What's the unit for speed?
Meters per second.
Am I multiplying that by
Time, which is seconds.
what's gonna happen there? Watch.
DS will cancel out, leaving just the M meters.
Right, because we measure distance in meters. So everything is make perfect sense. Right. So let's multiply. 3 by 10 to the power 8 multiplied, and I'm gonna recall the original answer, equals to 9.4608 by 10 to the power 15. So she just round out of the three significant figures for me. What would that be?
9.46 multiplied by 10 to the power of 17.
15. That's 15.
Okay.
Yeah. Right? And obviously it'll be meters, right? And I'll put the whole work into the side for anybody that might be interested. Meters per second by second. Yeah. Is there anybody that did not understand this question? Tell me. Shit, were you confused by anything I did?
No, sir.
Isaiah, did you get this answer?
Yeah.
Yeah. Sheena, did you get this answer?
Yes, sir.
Yeah. Okay. Great. Let's do question 5 now. And we'll move on to the new topic that I wanted to start today. So, for those who did the homework, did you all draw the diagram or did you all use the formula?
I did both because I didn't realize until after that it stated to do one, even though I know, like, yeah.
Well, big up you, Sheena. Sheena, use the easy. Big up you. Big up you. Right? Isaiah, how did you do it? Did you do the formula or did
I
you?
wanted both.
Wait, there's some dedicated people in class. Shay, probably feeling a little shame now.
That's not my fault.
Wait. Okay. All right. So Isaiah and Shay now, they can take a little break. I want to stress Shay now. I want to stress Shay out. So Shay, read the question there.
The two figures below show a plane going north and being affected by the wind blowing in different directions at a magnitude of 30 kilometers per hour. Figure 1 shows the wind blowing at a right angle, 90 degrees to plane, while figure 2 has the wind blowing at 120 degrees. Recreate both situations as vector diagrams using an appropriate scale to draw the resultants and state the magnitudes of the resultants. Use a scale of 1 centimeters per 10 kilometers per hour for both.
Shay, like he wasn't taking any breather. You just going. He was like Eminem there. He was like a rap god. You realize he didn't take a breather. He's just like the two figures below show up playing on the going north and going. All right. So Shay, what you want to do? You want to use the formula or you want to draw the diagram? What you want to do?
Can I want to use the formula?
You want to use the formula?
Yes, please.
Okay, cool. Because by now we know how to draw the diagram, right? All of us know how to draw the diagram. So for the sake of time, formula. What's the formula?
Or BD, or
Yeah, summon again.
R equals to the square root of b squared, a squared plus b squared plus 2 ab cos
R is equal to
the square root, like everything square rooted, a squared plus b squared plus 2ab, and then the cos function.
2ab cos what?
Theta.
Right. Now, Shay, I could blow your mind here, no? I'm blow all their mind. Isaiah and Shay, now check this out. Shay, if I were to complete this diagram, what kind of shape is this?
Rectangle.
Okay. And the resultant will be given by the diagonal. And we discussed that last class.
Yes, sir.
Okay. Would that diagonal and this diagonal have the same length?
Pythagoras theorem.
Yeah, yeah. You see it. You see it. You could use Pythagoras theorem. And the cosine rule, if you want, I can show you the proof for the cosine rule. The cosine rule, you actually have to use the Pythagoras theorem twice. And so the cosine rule is just the Pythagoras theorem, but because you notice like this, and this looking real similar to the Pythagoras theorem, because like in the Pythagoras theorem, and you end up with a is equal to the square root of b squared plus c squared.
Yes.
Yeah, so the cosine rule is just a variation of it's a better version of the Pythagoras theorem. They use for they use when it's not 90 degrees. But because this is 90 degrees, you're gonna see you are gonna see what's gonna happen, right? You're gonna be like mind blown. But if you wanted to do this, and now that you see his Pythagoras theorem, and you could just say r would be equal to the square root of 80 squared plus 30 squared. Yeah, you can do that.
Yes, sir.
Yeah, yeah. You're gonna see what's gonna happen over here. You're gonna be science so cool. It's just so cool. Yeah, so Shay, tell me what to plug in into the formula, and you're gonna see something really cool happening. So what's A and what's B?
A would be the 80.
Right? 80 squared. What B? B.
B would be the 30 squared.
That'll be 2 by
And
80 by 30. And what's the angle?
the angle would be 90 degrees.
Now, hold on to your pants. You're about to be mind blown. So we just now said that this is Pythagoras theorem, right? Yeah?
Yes, sir.
And if we use Pythagoras theorem, the resultant is supposed to be equal to the square root of 80 squared plus 30 squared. And
Yes, sir.
what is that? I wonder what cos 90 is, boy. Let me see. What is cos 90?
0.
So we're gonna happen to all of this.
Oh my God, it just cancels out because it's 0.
Yeah, and I'm gonna give you the Pythagoras theorem because the cosine rule, which is the parallelogram law of vectors, is made using Pythagoras theorem. And given the angle of 90, it'll just revert back to the regular Pythagoras theorem formula. Yeah. Isn't that cool?
Yes, it is.
Yeah. So you can just end up with 80 squared plus 30 squared, which is we discussed the Pythagoras theorem. Isaiah, did you see that? Wait, did you know that?
No, no.
No? Okay. Shina, did you see that this is Pythagoras theorem?
No, sir.
No? Okay. But you see it now, right? Because if you draw the
Yeah.
diagram, you form a right angle triangle here. And it's just Pythagoras theorem. We know this side is 80. We know this is 30. Yeah, very cool.
Yes, sir.
So what did you all get for this?
Oh, 84.4.
84.4.
Yeah, kilometers per hour.
Great. Great. Yeah. All right. So let's do the other question quickly. Do you all think the other question is Pythagoras theorem or nah?
No, sir.
Nah. Shay, I want to take a little detour because I feel like you like maths, you know. And Sheena, I'm not sure how much you like maths. I feel like you're kind of iffy about it. I feel like I don't know. I get the vibe that once I get the answer, it's like whatever. I get a vibe. Is that true or like you like maths?
Yes, sir. That is true. I'm more of an English person.
I I could read my students. Shay, you seem like you might be interested in the theory and the science and how it working a little bit. That true?
I don't know. I really,
No, but
I'm not
like
sure.
no, but like when I did this, I could hear the excitement in the voice. It was like,
Mommy, do you think I'm interested in maths?
what is it now? What is it?
I asked my mom and she said she thinks I'm interested in maths, so
Your mom thinks you're interested in maths.
yeah.
I think you're interested in maths. Watch this, right? So imagine you have this triangle. It's clearly not 90 degrees, right? It's clearly not, right? It's clearly not 90 degrees, and
No.
it's actually 120 degrees. But let me show you something. Check this. If this is 80 and this is 30, what's gonna happen? If you cut this in half, you're gonna end up with a what kind of triangle?
Pythagoras theorem.
Well, not quite, not quite.
A right angle triangle.
Right? You'll end up with a right angle triangle, and you'll also end up with a right angle triangle over here. Hence,
Yes.
okay. Now, this would be 80, this would be 30, and you would need to figure out how this was split. So you'd have angles there, and you need to figure out how it was split. Now, I'm not gonna go through the whole proof, but the thing is, what you would end up doing is you would end up having to use your trig ratios, right? You'd have to use the trig ratios, and when you use the trig ratios, you would end up getting a measurement for that side, and you would get a measurement for that side, and then you would add it together. And that's how you get the cosine rule. That's the proof for the cosine rule. And you did trig ratios, right?
Oh, yes, sir.
Yeah. I'll make a TikTok video about the full proof. That's really cool. Right, so let's just plug this into the formula fast and get the answer. Shana and Isaiah, when you all did it, and you all did the actual diagram, did you get something close to 84.4? Isaiah and Sheena, did you all get something close to 84.4?
The first diagram.
Yeah, the first diagram. What did you get when you measure it and multiply it back by 10?
Oh, I got 86.
86. Oh, that's fine. That's fine. Right? Wouldn't be exact. Okay. Let's do this fast. I feeling lazy. Let me just copy and paste this thing. Right. Oof. I feel like today's a real good day to sleep on our reels. I feel like today's a good day to sleep. Or maybe every day is a good day to sleep. What do you think? I suppose not. Right, so 80 squared plus 30 squared plus 2 by 80. Oh yeah, sure. What time did you wake up today?
Mm, like 6.
6? Okay, that's good. Isaiah, what time you wake up today?
5.
5? Wait. And I wake up 2:55. Well, in the morning, AM. That would not make sense if I was thinking now. It's like now it's 2:55.
So what you got for your first answer? Like you could just like look up on the screen.
I got 84.4. Did you get that?
It's 85.4.
Let me see. I wonder who told me 84.4. 80 squared plus 30 squared. Yeah, it's 85.44.
So it's only when you asked me about the diagram that I saw that it had only got 84.
Don't know how that happened. Right, 85.44. They never specified if to run it off the three significant figures or two decimal places, so I'll just do two decimal places. All right, and for the other one, are you getting 70?
Yes, sir.
Cool. Yeah, let's move on. Right. I'll give you all some more questions for homework. Shay, I'm looking at you. I wouldn't give all of this, right? Because I'm not heartless. But
So you're plotting the homework before class done. That is never a good sign.
say that again.
You are plotting the homework before class done. That is not a good sign.
Oh, that's not a good sign. Funny that you talk about plotting. This look like you had a plotter graph.
Yeah. Mm-mm.
uh, I'm not heartless, don't worry, don't worry. So let me move on. By the way, do you all remember stable equilibrium? Do you all remember the three types of equilibrium? Yeah? No? Could somebody tell me what are the three types of equilibrium? I have three people in class. Shay, give me an example of a type of equilibrium. Why the place so quiet? Shay, do you remember the three types of equilibrium?
All I could remember is a scale.
We'll look back in the book and tell me one of the three. There are three types of equilibrium. You need to remember this. Tell me one. I know you all sent me the diagrams, so I know it's in the books. Shay, while you look, Shay, now what's a type of equilibrium?
Stable equilibrium.
Unstable equilibrium.
Okay, stable and unstable. Isaiah, what's another type of equilibrium? The last one.
Neutral.
Neutral. Cool. All right. Did you all remember this experiment to find the center of gravity for an irregular shape?
Yes, sir.
Yeah, okay. right? Forces. Did we reach here last class? Do you all have this note in your book?
So the last thing we did was the experiment before.
Okay.
So we said we started forces.
Okay, so we didn't start this one.
No, sir.
No? Okay. All right, so we'll start forces today. And so you know them pimple patches. Shina, you know what I'm talking about? Them pimple
Yes,
patches.
sir.
You don't find this looking like a pimple patch?
Yes, sir.
Yeah, I find so. Yeah. I I find that's like a waste of money. But anyways, Shina, read forces for me.
Forces enable masses to overcome inertia. That is, they are able to cause a change in an object's acceleration, deceleration, or direction, even shape and size, but not mass. Forces are measured in newtons, which can be derived as 1N equals 1 kgm over s squared.
Okay. Shina, why do you think a force could change shape, size, but not mass? Shina, do you remember the definition of mass? Does anybody remember the definition of mass? Mass is the amount of what in a body?
Mass is the amount of
Matter.
yeah,
Matter. You can't change the amount of matter, right? Okay, cool. All right. Forces are measured in newtons, which can be derived as. Let me show you all the derivation one time. So does anybody know the formula for force? Force is equal to what by what?
Mass and acceleration.
Right. Could somebody tell me what is a unit for mass? What do we measure mass in?
Kilograms.
Kg, right? What do we measure acceleration in? Does anybody know? Shane, acceleration.
Um,
Oh, Shana, tell me.
oh, sorry. Is
Tell me.
it not ms minus 2 or m
Yeah.
over 2? I mean m.
Yeah, you're correct, Shana. Shay. Uh, you seem a little rusty, a little rusty. Little rusty. Isaiah, I presume you know this stuff. Acceleration is ms minus 2 meters per second squared.
Hmm.
All right, Shay, how come you're so rusty?
I'm not feeling good.
You're not feeling good? Okay. I'll get a blight today. Not next class, right? Unless you continue to feel bad, in which I will have to ask you, Mom, if you're feeling bad still, right? So F is equal to kg ms minus 2. Shay, do you understand where the derived quantity comes from?
Yes, sir.
Cool. So F is equal to mass times acceleration. M is mass, A is acceleration. So I'd like you guys to copy the definition down for forces. I wouldn't make all the copy down the type of forces right now. You could copy down for homework, but not right now. That'll take real long. So just copy down what are forces, right? And you could just write examples, right? And you could say examples, gravity, friction, weight. Yeah, so what I want you guys to do is just copy this part down for me. So copy down the formula. F is equal to ma, right? So the heading is forces. Write the formula, and then write the definition, and put the examples. I'm giving you all 4 minutes. Shay, are you finished copying on everything?
I'm just copying down the types, not like the definition, but just the types.
Okay, cool.
So can you scroll along so I can see the rest?
Oh, you want to copy on your rest? Okay, sure. You don't have to, but yeah, go ahead. So those are all the types of forces.
I'm done with everything.
Okay, Shayna, what about you?
And then again,
Isaiah?
I'm done.
Okay, cool. Right? So somebody just remind me, what do we measure force in? Force is measured in what? Guys,
Newton.
newtons, right? Shay, a force is an example of a vector quantity or a scalar quantity.
A scalar quantity.
No. Remind me, what is a vector quantity? Tell me the definition. Shay, what's a vector quantity? It should be in the notes. We did that the other day.
Um, I'm looking for it.
All right.
That the vector quantity is the one that like isn't just dependent on the magnitude, but is also dependent on the direction.
Yeah, and let me ask you a question. Could a force be in different directions?
Yes.
Yeah, so that can be a scalar. Right? So you would see sometimes -5 newtons, +5 newtons. Right. Sheena, did you know what a vector was from the previous classes?
Yes, sir.
Okay, cool. All right. So these are some forces. Cool. Right. So Sheena, read that text to me. Forces may be,
Forces may be contact or non-contact. They may also be absorbed, such as by knee pads worn by athletes, cyclists, helmets, bubble wrap packaging, and cell phone cases. When a force is absorbed, its impact is decreased. All moving objects on Earth experience some form of resistance, whether from the surface they are on, friction, or the medium that they are in, such as the atmosphere, called air resistance or drag.
all right. So Sheena, you ever obviously you went to the beach, right? Where are you able to move more freely? On land or in the sea?
On land.
Right. That's because there's less drag, right? There's less resistance, there's less friction. So just by you being here, your body is experiencing a bunch of forces. So do you all know about air resistance and something? I'm not sure if any of you all into F1 racing. I suppose not. But imagine you have a car going forward. The thrust will be the force propelling the car to move forward. So, Shay, do you know what trust is? I don't talking about
Yes.
anything in relationships, eh? I don't
What?
talking about I'm not talking about that kind of trust.
I was thinking
Talking
up trust and that kind of stuff, like
up
you're
trust and down
pushing it
trust.
up.
Okay, good. So, what would generate the trust in a car?
The gas pedal and the engine, and
Or the engine, right? Engine would
yeah,
generate the trust. So you have the car moving forward, so that's the thrust. So that would be a force going. Okay, in this diagram, what direction is that force going in?
That'll be the right.
Right. And then we have these forces acting against it. We have air resistance and friction. So, guys, what would be the net force the car would experience? Let me see if anybody can figure that out. What would
It'll
be,
be
tell me,
it'll be still.
you say would be still? Could you explain that?
When you add the air resistance and friction, that will be 1200, and the thrust is also 1200 newtons.
So it would cancel off,
Yeah.
right? So you can think of this force as positive, so that would be 1200 newtons. And you can think of this force as being negative because it's in the opposite direction. So Shayna, what's the force being experienced by the car?
0 newtons.
And if there's no force, then can the body overcome inertia? What is
No, sir.
no? Do you all know what inertia is? I'll look at you real with me. I don't judge anybody. I'll look at them. Shayna, you know what inertia is?
So do you think from the law, Newton's law?
Yeah. But do you actually know what it is like logically, like example in real life? Do you know what inertia is?
Inertia is when you're. Oh, wait, can I answer?
Sure, sure. Good answer.
Um, Inertia is what, like the standstill of a thing, and like when you overcome it, that's when you move.
Yeah, I hear what you're saying, but I want an example of inertia. Do you all know what inertia means? Shannon, Isaiah, do
So,
you all know what
so it's like the tendency to resist the change in motion.
you're reading that from ChatGPT or Google?
So not none.
None? Okay, well, yeah, that's correct. That's what I want to hear. So, guys, um, who would I think it'd be easier to move? A fatty or somebody that real skinny?
Get you?
Somebody who are asking me.
Somebody who's skinny, right? And that's because if somebody has a greater mass, then you'll have to apply more force for they to experience a change in motion. So inertia is a body's ability to resist the change in motion by virtue of its mass. That's what inertia is. So you think if something moving, it will be easy to stop it, right?
No, de dependent.
So like imagine a truck moving.
No,
That'll be real hard to stop it, right? Because it would, in other words, you would require a great force to overcome the moving struck inertia. So inertia is just an ability. So inertia is just the ability of a body or an object to resist the change in a motion. So I'll write that down. So what is inertia? Inertia is a body's ability to resist a change in motion.
isn't that it Newton law?
Yeah, yeah. So you all did all of that already.
Yes, sir.
Yes,
Okay,
true.
cool. Okay, cool. So inertia is our body's ability to resist a change in motion, right? Because in the third law, and it says that every action has an opposite or equal reaction.
Yes, sir.
Right. Now, and then there's also the law that says a body will remain at rest unless acted upon by an external force. You all know you all know which one I'm talking about there?
Is that the first one?
Yes.
Um, yeah, I think so. I should know the order, right? I should know the order, but I just know the theorems. We'll check the order just now. I just know the theorems. It kind of embarrassing as an electrical engineer, but I'll be honest, as an electrical engineer, we don't use our rules. We don't use our rules. We just be doing crazy maths, right? But we'll check the rules. The main thing is I understand the theorem. So the Newton's theorem that says, if you have a body, so guys, and so I could visualize, if you have a ball on the ground, if you don't apply a force hit, would it move or would it stay there?
It would stay.
It would stay there.
it would stay. And to get it to move, right? And you would need to apply a force.
Yes, sir.
Yes, sir.
Yeah. And if the force is not great enough, then you would not be able to overcome the object's or body's inertia. So copy this down. Inertia is a body's ability to resist a change in motion, and you can add in this by virtue of its mass. By virtue of its mass. Isaiah, if a body is in motion, would it possess less inertia or more inertia? So here what I'm asking, right? If a body is in motion, would it be easier to change its its motion, or would it be harder? Isaiah, I'll say that one more time. If you have a body moving, would it be easy to stop it, or would it be hard to stop it? What do you think?
Hard.
It would be hard. So inertia is a body's ability to resist a change in motion by virtue of its mass and acceleration. So those things would define a body's inertia. As soon as you have that copy down, let me know.
I have everything copied down.
Okay,
Same.
great. I just hope that, or they could see physics through a common sense lens, because physics is common sense. Yeah, right. You could remove acceleration. You could remove acceleration from the definition. That's not 100% correct. So just leave mass, right? Because not all the time a body will possess acceleration. But and all of us could agree that a body will always possess mass. I don't understand what I'm saying, like, just by existing, don't you have mass? Yeah or no? Actually, like, just by you existing, don't you have mass? Like your body has mass, right?
Yes, sir.
But if you're sitting down still, is your body accelerating?
No.
No. So mass is something that's constant, acceleration isn't. And that's why you shouldn't put it in the definition, because acceleration can change, right? Cool. All right, so in this example, the two resistant forces are equal to the applied forward thrust of the car. This will give an overall resultant or net force of 0 newtons. This doesn't mean the car will stop. This means that the object is in equilibrium and is moving at a constant velocity. Therefore, we can say that if a force is absent, there will be no change in motion or direction. Now, Shay, that's a bit weird to understand, right? They're saying that it doesn't mean the car will stop. That sounds weird, right? They're saying that the car wouldn't stop. How do you feel about that? And logically, you're thinking that it should stop.
I feel like I feel like in a sense it just wasn't moving in the first place.
Ah,
That's what I'm thinking about it. I feel like it's just staying still.
okay.
Like the
Um,
force was never there to begin with, because they were just automatically canceling each other out. So
right. And Shay, do you know what acceleration is?
yeah, when you're increasing the speed.
Okay, and to increase speed, won't you need to apply an external force to change the speed?
Yeah, so
So you see where I'm going with this. If there's no change in force, or if there's no application of force, can a body accelerate?
No.
No. So that's why they are saying this doesn't mean the car will stop. This just means that the body is in equilibrium and it's moving at a constant velocity. So Shayna, if there are no external forces on a moving body, is the body accelerating or is the body moving at a constant velocity? Shayna, you want me to say that one more time? Oh, yeah, constant velocity, yes. So Shayna, understand. Shayna, if you're running, right? If you're running, right? And you're running at a constant speed, right? Are you accelerating or there's no acceleration? So you're running at a
No.
constant speed, no acceleration, right? But what if somebody pushes you? Will you accelerate because of that?
In which direction? In the direction I'm moving?
It doesn't matter.
Okay.
If they push any direction
Yes.
you're moving in, you would accelerate. If they
Mhm.
push any opposing direction, maybe you might decelerate. But if they push it hard enough, you could just accelerate in the opposite direction, right? So Shina, um, the whole point of it is if you're moving at a constant velocity, that means you have no external forces acting on you. In other words, the net force on you is zero. But if somebody pushes you, wouldn't that change your motion? Yeah or no?
Yes, sir.
That would change your velocity. And if there's a change in velocity, there's acceleration. So I would like you all to copy down this example. This is a very important example you need to know about. So Isaiah, did you know that if there's no net force acting on an object, it could be moving?
I think so.
You think so? Okay. So copy this down. I'm interested in seeing how well you're gonna draw the car. If you can't draw the car, just draw a ball or something. You just draw something that moving. So Shay, before if somebody told you that there's no force acting on an object, would you think that it's moving or
I think it could be moving or it could be still.
okay, cool. Would you have had known that there was no acceleration logically?
But no, there's no acceleration.
Yeah. Because if I tell you that there's no external forces, in other words, the net force is zero, would you have interpreted that as there's no acceleration?
Yes.
Yeah, okay, cool. Because you need a force to change our body's motion and change our body's velocity. If there's no if there's no external force to act on our body, then it can't really accelerate. So as soon as you all have this copy down, let me know and I'll move on. Shina, I want to bring something to your attention. You remember that law of motion that Newton said? He said that a body at rest will stay at rest unless acted upon by a force. And Shina, if you hit a ball, enter the start, you would apply a force,
Yes, sir.
but put let me ask that question and think about it logically. Enter the start, I would have applied a force and that would have caused the ball to move.
Yes, sir.
But well, but then the ball continues to roll without me constantly putting a force.
Yes, sir.
Think about it. You hit any ball once and When you hit the ball, that's where you apply any force. But any ball still rolling?
Yes, sir.
Yeah, so notice in the note they're saying the car does not require a force to keep moving. The same way like the ball. If I hit a ball once, then it does not require a constant force to keep moving. It will move nonetheless. And you will see that the ball is in neutral equilibrium there. Right?
Yes.
You only need a force to either accelerate something or decelerate something. So as soon as you all have the diagram and the notes copied down, let me know. All right, so Isaiah, when you have everything copied down, you'll tell me and we'll move on. Um, Shay, are you drawing a car or are you drawing? What are you drawing with the diagram?
I just drew up a picture.
Oh, I can't wait to see it. Isaiah, what are you drawing? Are you drawing a car? What are you drawing? Isaiah? Optimus
I'm gonna
Prime?
send you a picture.
What the hell? You're gonna draw Optimus Prime. Autobots roll out. Oh, that's hilarious. I like that. All right, and make sure and copy down the note. In this example, the two resistant forces are equal to the applied force. Make sure you have all of that copied down. Yeah, the main thing I want all you to take away is that just because the net force is zero, that doesn't mean the car is stationary. What that means is the car is not accelerating. It's moving at a constant velocity. That's what I wanted to just keep in mind. Yeah.
Do you have to write everything in the box?
Yeah, yeah. You see, that's so sad. It's like, oh, more writing. I understand. Yeah. But it's peak information. You have to know that. I can imagine in CXC being like, okay, they give you a diagram and they ask you, is this body in motion? Is the acceleration constant? Yeah. Not no acceleration constant. Is the velocity constant? I can imagine them doing that. Yeah. Right. So Isaiah, I'm gonna send your diagram on the chat. It's very beautiful. Ladies, I can't wait to see all the drawings. So at the end of class, I'm going to pick you all up on theory that they should have learned thus far. Right? Okay.
You're vlogging again? Teach it now, right?
Yeah, so just prepare yourself for that. So Shea, looking at you specifically, because I know you say you're a little rusty. Shay and Sheena, did you all finish with the diagram?
Yes, sir.
Yeah, okay, cool. Okay, you all taking a little while, a little long.
I
Uh,
just finished.
just finished? Sheena, what about you?
So I reached accelerate almost now.
Okay,
So I finished.
okay, cool. All right, let's move on. All right, so let's look at air resistance and terminal velocity. So does anybody know what terminal velocity means? Before we copy down notes and things, does anybody know what it means? Terminal velocity. Sheena, Isaiah, does anybody know what terminal velocity means? Or like tell me no. That's fine. Tell me
No,
no.
sir.
No?
No,
Okay.
sir.
Um, you see how hard that was? If you don't know something, say no. It's a place to learn. So Isaiah, do you know what terminal velocity is? Can I hear it from Isaiah? Okay, I see you on mute. Yeah or no?
I think is when something stops accelerating.
Yeah, that's correct. Right? So Shay and Sheena, imagine you throw a ball from, I don't know, from like maybe you just throw a ball, right? Let me just say you drop something. Wouldn't, okay, let me just say you drop your phone. If you drop your phone, wouldn't the phone accelerate because of gravity? Yeah or no?
Yes, sir.
Yes.
Wouldn't gravity pull the phone downwards to the center of the earth? That's
Yes,
what would
sir.
happen.
Yes, sir.
Now it reaches a point where the phone would stop accelerating. Here we're saying, so all you understand that if I drop something, it's gonna accelerate, it's gonna start to speed up, going downwards. Now, if you drop something from a really high spot, over time, it's gonna the acceleration is gonna decrease and it's gonna start to move at a constant speed. So why is that? Do we know about air resistance? Do you all know about drag and air resistance?
Never did it, so
Say that again.
I never did it, so
Okay. Um, do you all know that air is a fluid like water? Yeah or no?
Yes, sir.
Yeah. Um, she, do you know that air is a fluid?
yes, sir.
Okay. When you're in the beach, right? If you slap the water, wouldn't you? How does it feel? Tell me, how does it feel?
Your belly flop, it is it.
Okay. And so if you slap the water, wouldn't the water resist the change in motion?
Yes, sir.
Yes, sir.
So wouldn't the water slow you down?
Yes, sir.
Well,
Yes, sir.
air is the same thing. If you drop something, the air is going to slow down whatever you dropped. And imagine you drop something. If you drop something, wouldn't there be wind blowing upwards? And wouldn't that affect the acceleration of the ball? Because remember, and if a force acts on an object, wouldn't that cause the object to accelerate or decelerate?
Yes, sir.
So you have a bunch of forces acting on the ball. And eventually, these forces cancel off. And guys, when a force, okay, when the forces on our body cancel off, what does that mean about the body? If the forces on our body cancels off and is zero, the body is moving at a constant what?
Velocity.
Right. So terminal velocity just means the point at which a falling object stops accelerating. So it's moving at a constant velocity. Right? So let me just say somebody get pelted off a plane. It looks so, right? This person look like they get pelted off a plane. Wouldn't they start to accelerate downwards because of gravity? We see it now, right? Makes sense.
Yes.
Right. As speed increases, so does drag. Let me give a practical example. Let me go back to the beach. So if you gently pass a hand through the water, and you can do that, and it wouldn't be that hard, right? You know, like if you gently pass a hand through the water, and you can move your hand fine.
Yes, sir.
If you try to do it real speed, like you hit the water, what happen? Tell me, Shay, if you try to move very fast in water, the water will resist it. But if you're moving slow, and you could cross your hands through the water relatively fine.
Yes, sir.
So that's what they're saying over here. They're saying as speed increases, so does drag. Drag pulls it back, and that's a property of any fluid. Right. So, Shay, at the start there was one force, but how much forces we have now? Two. We have drag and we have gravity. These are going in opposite directions, so eventually they would cancel off. Let's see. So the drag, so Shay, you understand that as the speed increases, the drag would increase. Yeah or no?
Yes, sir.
Cool. And it's saying until drag equals weight. So drag is an example of a what? Tell me, Shay.
Of course.
Drag is an example of a force, right? Drag is equal, well, is a force. Drag is a force. Bodies would fall and accelerate to the ground because of their mass, right? We know that. And because we are on Earth, those bodies would possess a weight. So, guys, and everybody understands that because we are on Earth, the weight would be equal to mass times gravity. So gravity is what gives us weight. Are you understand that, right? Because if you go on a different place, like Saturn or something, and your weight would change. Stay with me.
Yes, sir.
So think of the forces. So Shayna, drag is a force, and it's saying here that as speed increases, so does the drag. So Shayna, you fall out of the plane, and your speed is increasing because of gravity, because you have weight. And so Shayna, weight is also an example of what? What is weight an example of? Tell me, Shayna, what's weight an example of? Weight is also a what? Anybody tell me? Weight is a what?
The force, well, the force of gravity acting on the object.
So weight is a force, right? That's what you're saying,
Mm-hmm.
right? So here what? When you initially would have dropped out of the plane, you would have been accelerating towards the ground. But you would have experienced drag, and as your speed increases, the drag would increase. Now this would happen until the drag equals weight. So, Shayna, your weight, do you think the weight would act downwards or upwards? What do you think, Shayna? Weight. Weight is our force. Do you think weight would act downwards or upwards?
Downwards.
Right? So weight is a downwards force. Drag. Do you think drag would act upwards or downwards?
Upwards.
Upwards. So what's gonna happen? If your speed increasing and your drag increasing, and you're gonna reach a point where these two forces equal, and if these two forces equal, what would happen?
They'll cancel.
They'll cancel off. And your body will be experiencing a force of what? If they cancel off, that's how much newtons?
Oh, 0.
0. And if your body is no longer experiencing a force, then you'll be moving at constant,
Velocity.
right? And the proper term for that is terminal velocity. And that's it. That's it. Right? So that's the basic part you need to understand. So you understand that, right?
Yes, sir.
So again, they could ask you to describe this scenario. They could ask you to describe terminal velocity. And you would have to tell them, because of gravity, you would accelerate towards the ground. But as you accelerate and your speed increases, you would experience drag. The drag would eventually equal to weight. And because it equals to the weight, the forces would cancel off. And so you'd be moving at a constant velocity. And that's what terminal velocity is. Shay, are you confused by anything I said?
No, sir.
No? Okay. Right, so you could copy this down. And this would be under air resistance and terminal velocity. So air resistance. Yes, so Shay, terminal velocity just basically means that you're going at a what?
Oh, what's the question?
Terminal velocity just means that you're moving at a what?
I just like slow down speed. Just
No, at a constant velocity. Terminal velocity means constant velocity. Do you know why?
because there's no like force or like any forces opposing like the motion.
Yeah, but I want to hear why. So She just run me through the scenario quickly. The man follows at the plane, what happen?
As he falls down, the drag increases with the gravity until it's equal and then it remains constant.
Um, so I feel like you have it. I feel like you understand it, but I'm just gonna go over it one more time. So she, stay unmuted. So because of gravity, the person would fall down, right? They would because they would have weight. They would have weight. So weight would be
Yes.
acting downwards, and as they fall, so she, if you're accelerating, what's going on to your speed? Is your speed
It
increasing?
changes, in increases.
Right? So as your speed increases, so does the drag. So your weight is pulling you downwards, and the drag is pulling you upwards. So it reaches a
So
point where what happens?
it reaches to a point where it's like equal to each other, the
Right?
drag and the axis equal to each other.
Right?
Well,
The
no,
drag
the
on the
weight.
weight. Drag on the
Yeah.
weight, right? Now it cancels. And so there'd be no the net force on the body would be zero, so it wouldn't accelerate. So
So
terminal
it just
velocity.
be gravity pulling you down.
Yeah, you can think about it like that. You wouldn't be accelerating. You'll be moving at a constant speed. So you all could copy this down. Right, and the heading is air resistance and terminal velocity. So terminal velocity just means constant velocity. So at the terminal velocity, A is equal to what? What do you guys think? A is equal to what? A means acceleration. So A would be equal to what? If it's moving at terminal velocity, that means the acceleration is
0.
zero. So A is equal to zero. Ladies, all you understand why?
Yes.
Cool. Shay, hope you understand that. At terminal velocity, A is equal to zero. Right? So you don't have to copy down the parts in the note. Just copy down air resistance and terminal velocity. And then copying down these points over here. Sure, I still feel like you like chemistry more than physics.
Yes.
Yeah. Is it that you do better in chemistry than physics?
Yes.
Why you think that's the case? Like why okay, what
I
was the
feel like it
last
just I feel like it just naturally comes to me better.
but you see how much like this is all of this is just logic. Like this just makes sense. Okay, so like
It
what are your grades usually in physics?
like 82 and stuff,
Okay, and in chemistry.
89 and stuff.
That's not a big difference.
Yeah,
And
but like I still good chemistry.
okay, okay. Sheena, what about you? What do you usually get in physics?
Usually 80s.
Okay, and chemistry?
Chemistry is 90s. So
What? Okay. Isaiah, what about you?
80s for physics and 70s. Fuck 'em.
You see, I can relate to you. I can relate to you. I can't relate to them girls. I don't know. I feel like physics has come more naturally to boys, and chem for girls. Because in my class, the girls would have done better in the chemistry than the boys. Yeah. Actually, I'm not sure if you know who Marie Curie is. Do you?
Yes, I do.
Oh, okay. Shina, you know who that is?
yes.
I surprised. How is that people don't know who that is? Yeah, shit, I'm gonna be you in a couple of years. Minus the dead parts.
Well, I don't know about that.
Okay. All right. So as soon as you all have this copy down, let me know. Let me know. Right, I'm back. Did you all get through? Are you all finished?
Almost. So we're not writing what in the box, right?
Nah, not as what inside the box.
All
Leave
right.
it out. Leave it out. All right, so we done?
Yes, sir.
Yeah, okay. All right. Do you all know what free fall is? Free fall.
No, sir.
No? What does it sound like, Shana? Like logically. If you hear free fall, wait, like if you hear somebody mention that, you think you'd be able to figure out what that means? Or like now? Free
Um,
fall.
like when something falling down with only like gravity acting on it, like it's falling straight down without the other forces acting on it.
I hear what you're saying, right? Because it says free fall, right? So it just fallen. Yeah. Right? So that's correct. So when an object is accelerating due to gravity only, so Shina, imagine you drop something. If nothing, if it just falls, so for instance, if you take a pencil right now and you just drop it on the ground, right, that would be free fall because nothing else is causing it to accelerate other than gravity. Understand?
Yes, sir.
So, Shay, free fall. Do you know what free fall is?
It's basically just when like an object is taken over by gravity, you let gravity control the object alone.
Yeah, and they just fall because of gravity.
Mhm.
Um, do you all know the formula for acceleration? I'll show you guys how to figure it out using the definition. Shay, do you know what acceleration is? The definition to it?
That is the ms. It's -1 or -2?
MS minus 2, but do you know what? Could you tell me what acceleration is?
Basically, like change in speed or
Change in speed. So acceleration is not just change in speed, it's the rate at which you change speed. So in other words, how fast are you changing your speed? So acceleration is just a change in velocity, right? So change in velocity all over time taken. That's what it is. So that'll be A is equal to V minus U all over T. Does anybody know what V would be? What is,
Final velocity minus initial velocity.
right, final velocity, right? And U is the initial velocity. So in other words, acceleration is the time it takes for you to change your velocity. That's what it is. Is this formula looking familiar or no?
I don't think we really went through like acceleration by itself or like free fall. Like we got introduced to it, but like we didn't go in deep.
Okay, no problem. So let's check out this. So at the start, at 0 seconds. Why, by the way, why is she looking like a witch so? Is it just me or I find she looking like a witch?
Yes.
I you see what I talk Isaiah, you see what I'm talking about?
Yeah.
I feel she throwing this ball to hit somebody on the head, you know. I feel she doing some OBA here. I feel that what she up to. But at 0 seconds, what's the velocity?
0.
0, right? So U will be equal to 0 meters per second, ms minus 1. Let's just take 5 seconds as the final velocity. Let's just say we measure the speed at this point and we get 50 meters per second. Right? By the way, meters slash second and ms minus 1 means the same thing. I just reiterating that. So if the final velocity I measured was at 5 seconds and it was 50 meters per second, what would V be equal to?
It will be equal to the 50 meters per second.
Right. So what was the change in velocity? I went from 0 to 50. So what's the change in velocity?
50.
50, right? So 50 minus 0. And what was the time it took to change that velocity? So it went from 0 to 50 meters per
5 seconds.
second in 5 seconds. Right? So your acceleration is 10. And let me show you how we're going to figure out the units, right? So, guys, any unit on top is for velocity. So any unit on top would be ms minus 1, yeah or no? If you're confused by that, tell me no. Shina, are you confused by the unit on top being ms minus 1?
No, sir.
No? She, are you confused by that? She?
No, sir.
No, because on top, it's final velocity minus initial velocity. So on top, we have velocity. Velocity is measured in ms minus 1. And in the bottom, we have time taken. What do we measure time in?
Seconds.
Seconds. If you take the seconds and you bring it up to the top, what's going to happen to the powers? It's just add mass. What's going to
They
happen?
just cancel each other out.
No. Mm-mm. This is understood to be
Oh,
s
it
to
will
the
be
power 1.
negative two, because when you carry it up, it will be -1.
Negative 1, negative 1, negative 2. Right. So everything makes sense. Right? And that's why the unit for acceleration is ms minus 2. Now, if you take exact measurements, you will not get 10. You will get something like 9.81, 9.82. But sometimes in physics, it is used 10. Right? That's what free fall is. So next class, we're going to move on to something very fun. We're going to move on to levers. Are we looking forward to that? I know a lot of physics students hate this topic.
I love it.
Good fun.
I I agree, but a lot of students hate this topic like with a passion. They really don't like it, especially with questions like this. That kind of tricky. Yeah, don't worry, we'll be doing some nice questions. So next class we'll be doing levers, principal moments, and we'll be doing. If I forget the time, I would like to move on to Hooke's law. So let me give all the homework one time. Again, I'm not a wicked, so I'm not gonna give all you too much homework. Yeah, just 8 or 9. Yeah, I'll just give all the 8 and 9 to do. Yeah, 8 and 9. Yeah, just 8 and 9. Right? So that'll be all the homework. So yeah, guys, thanks for coming to class today. Before we go, right, I just want to do a quick recap. Let me just make sure they know all the work. Shay, what is a vector quantity? And give me some examples of vector quantities.
A vector quantity is basically the magnitude and the distance, where scalar quantity is just the magnitude.
I think you meant to say magnitude and direction.
Yeah, sorry, direction, sorry.
Right. So a vector is a quantity that has both magnitude and direction. Magnitude is just a size. Give me an example of a vector quantity.
A vector quantity would be like a car moving.
That is not a quantity. A quantity would be like force. Force. So an example of a vector quantity is force. What else? You can't have my car moving.
Uh,
Imagine they ask you to put a quantity and you put a car moving. What? Shit. Hey, no, no. Shina, give me an example of a vector quantity.
Displacements.
Right? Displacement. Um, it have one or little saying. We look at it today. Starts with V.
Acceleration.
Acceleration and what?
Velocity.
Yeah, velocity. Right? Isaiah, give me an example of a scalar quantity.
Speed,
Speed was
volume,
volume,
distance.
right? All that. Cool. So you all know how to do rounding off, standard form, conversions.
Yes, sir.
What else I can pick all up on? What does terminal velocity mean? Terminal velocity. If somebody says they're at terminal velocity, what does that mean about the acceleration? The acceleration is equal to what?
0.
Right. So they would move in at a constant what?
Velocity. So
Great. If the net force on a body is 0, does that mean the body is not moving?
No, sir.
No. It means that the body is moving at a constant what?
velocity.
Right. So the acceleration is 0 again. Cool. Let me see if I can pick you all up on anything else. All right. What is the formula for what is the parallelogram law of vectors formula? R is equal to what?
The square root of a squared plus b squared plus 2ab cos theta.
Cos alpha, cos theta is the same thing, right? Just the angle. Nice. Um, cool. What is the formula for weight? Weight is equal to what?
Mass times gravity.
Right? Mass times gravity. What's the formula for force? Force is equal to what? Mass times acceleration. Is weight an example of a force?
Yes, wait. Yes, sir.
Yeah.
Yes, sir.
Give me an example of another type of force,
Friction.
right? Oh yeah, do go in people them exam and write love, eh? Do that. Isaiah, will you be doing that? They ask if I force, if I love. You know how people say love is the greatest force on earth? Shay, you ever hear that?
People say that.
Yeah, people say that. Like yeah, yeah. Let me look it up. Love is. Watch, look at autocorrecting. Watch. Don't go any people them exam and put love anywhere. Go do that. Yeah. All right. So some other forces are what? Are magnetic forces. What are some examples of other forces?
Drag.
Drag, right?
Nuclear.
Of course you had to say nuclear. Shay, you say nuclear?
Yes.
Yeah, of course you had to say nuclear. You want to bomb up in place.
No.
Yeah. I don't watch Shay now. I don't watch over Shay.
Yes,
Um, okay. What is the difference between precision and accuracy? We're going back far with this one. Um, let me just give you an example. So let me just say, okay, is this precise or accurate? What do you all think this is?
precise.
This is neither precise nor accurate. Because, I mean, okay,
Because it's inconsistent.
this precise, because like it's around the same place. But most of it kind of far from the target, so not very accurate. What if I were to draw this? Yeah, what would that be? Guys, is that precise? On a scale of 1 to 10, how precise would you say that is? How precise is that looking? Do you remember what precise means?
Yes, sir.
So precise is just okay. You
Not
can
consistent.
yeah, consistency, right? So Sheena, was this person relatively consistent?
Yes, sir.
Yeah. So if I have a medium precision, do they have a high accuracy?
Yes, sir.
Yeah, we're real close to the target. Great. What is the SI unit for current?
Amps.
Right? Amperes, amps. Cool. What would I use to measure um okay, now I wouldn't give all the example. Could somebody remind me what a period is in terms of a pendulum? What is a period in terms of a pendulum? It's the time it takes for
For oscillation.
a full oscillation, right? Why would I take okay, why would I want to measure multiple periods? Why would I time 50 periods and then find the average? Why am I doing that? What am I doing? What am I decreasing by doing that? If I take 50 periods and then I find the average time period, what am I reducing there? Starts with E. I'm reducing what? She. E. Whenever you find average or you take multiple readings, you're reducing what? She, do you know?
Oh, sorry, I was talking. What was the question?
I'm saying the more readings you take, right? Why do you want to take multiple readings in physics?
Oh, so it could be more accurate because of the reaction time.
Right? And as well as finding the average, right? Cool. What are some errors that could happen in a lab?
The I remember the parallax error was the
Parallax error, yeah? What else?
the environmental error, the reaction time.
Right? Cool. Sheena, how would I correct the parallax error?
I'll correct it
Yeah, how would I correct the parallax error?
by reading the appearances at eye level.
Yeah, yeah. 90 degrees to the substance. Cool. Um, okay, I feel pretty confident in where you all at right now. Um, how much seconds is there in an hour?
3600.
Cool.
Choose
If you see this symbol over here, this means 10 to what?
10 to the negative 6.
-6.
If all you see this power, what does that mean?
10 to the power 6.
Okay. If all you see this, what does this mean? Say it out loud. So this would
20.
be okay, yeah, centi. Right? What would this be?
Micro.
Micro.
And this is what?
Mega.
Right?
Mega.
Centi is 10 to what power?
-.
Right. Okay, I feel pretty confident in where you all at right now. Um, so so yeah, I will see you guys. Oh, let me just test you all on one more thing. What would be more stable? An object that is tall, an object that is short?
Short.
Short, and that's because the center of gravity is what?
Lower.
Lower, right? They bring this in physics, and they like to bring this. Okay, use common sense. I have a ball on these platforms here. Which one do you all think is neutral? Which one looks like neutral equilibrium? Neutral means that you can stay there. If you apply a force, it will roll.
The third one
The third
on the
one,
bottom.
yeah, I would say that this is neutral. Which one looking stable here? Imagine you have a ball and you have a ball here. Which one looking stable, more stable?
The first one?
The first one, right? If a hard wind blow, we're gonna happen to this ball.
Will fall off.
It will fall off. Right? So this is an example of stable equilibrium. This is stable equilibrium, and this is unstable equilibrium. Right. Do you all know the formula for density by chance? We didn't do it yet, but you should know the formula. Density is equal to
Mass over volume.
mass over volume. What would I measure mass in?
kg.
What would I measure volume in?
Mass cube.
Meter cube, right? So density is kg m minus 3. Cool. Is there anything else I could ask? No, I feel that's good. So next class, we're going to move on to levers and hooks law. Right. See you all next week. Later, everybody. Bye.